All right then. So in this sections, we are going to discuss about the arrays. So let me clean up the code. Okay. So let me open the multi-line comment. All right. So basically in C, an array is a collection of elements of the same data type. So array is a collection of elements of same type. Okay, so they are stored in contiguous memory locations, contiguous memory location. They are stored in a contiguous memory location. So each element in an array acts accessed by its index. Each elements in an array are accessed by its index number. Okay, so let me explain you in a very brief way. So let's discuss the important points that we need to memorize, and when it comes to an array, important points that we need to keep it in our mind. So basically, when I say index are nothing but their position numbers. So because always arrays are maintained in a proper order. Array is the only element stored in a sequential order in the memory space, other than the different variables are randomly put in a different memory addresses by the compiler. But array is the only element are stored in a sequential order, right? Because it will always starts from the index 0. So array index always starts from 0, right? So array size should be specified. The size of an array should be specified at the time of declaration, or it can be deduced from the deduced spelling mistake, sorry, it can be deduced from the number of elements, deduced from the number of elements during the initialization. Either you dynamically defer the size and give the values later, or give the values according to the values the array size will be detected, right? Then after that, array have a fixed size. So you should keep it in mind. Array, once you fix that size, you can't increase or decrease it. So array have a fixed size. So and the size cannot be changed, and their size cannot be changed during the run time. Okay, that's the most important thing that you should keep it in mind. So these are the things. And one more thing, so you should remember that C does not perform any array bounds checking. So it is crucial to ensure that you do not access an element outside the bound of an array to avoid the undefined behavior. So what I'm trying to say over here is, think about it, that you're having an array of 5 different elements, but you're trying to access the 6th element, which is not there actually. So it will behave, it will return as an undefined behavior. Like it's most crucial thing. It doesn't have that inbuilt options to handle that bounds error. So you should be very careful when you're working with the arrays. All right. So we have two different types of array, right? When it comes to types, we have two different types. One, dimensional, dimensional, and multi-dimensional. Okay, these are the two different types of arrays that we do have. So let's talk about the one dimensional in this section now. So let's see how to declare an one dimensional array. So let's see how to declare the one dimensional array. So you need to give the data type and variable, and you need to define the size. Here you need to define the size, or you can initialize the values over here. Value 1, 2, 3, and so on. This is how you can initialize. Either give the size or initialize the value. So based on that, it can be defined. For instance, int number equals to int number of, I can give the value was 10 something, a random numbers over here. Based on the size, it will automatically defines the size of an array. This is one way. Or you can simply supply the values as 5, something like this. So these are the two. This is initialization and this is initialization and this is declaration. Based on the supplied values, sizes can be defined, or based on the sizes, you can supply the values according to it. So if you fix the value over here as 5, you can't give the values beyond the 5. So when you're trying to initialize, it's better to leave it empty, right? So at this point, we might face some issue, because if you are keep on initializing it, but you might not aware of what exact size of your arrays. Think about it like if you are initializing a 6, 10, or dynamically initializing the values according to it, you might are not aware of what exact size of an array. So you don't know what exact size of an array is. So there are several ways to find the size of an array in an exact method. So we need to use the size of function to find out the size of an array. So I'm going to show you everything one by one. So next we need to worry about how to access this element. Think about it, we're having this number and I'm having the 5 different elements stored, and as I told you, array index always starts from 0. So the 0th index will be 1, and this first index, second index, third index, and fourth index. So the values will be stored in the array just like this way: 5, 1, 5, 24, 68, and 65. So the index positions will be 0, 1, 2, 3, and 4. This is how the index positions will be. So let's say if I wish to access the third position, so number of 3, it's going to return the answer as 68. So this is how you need to access it. So what exactly is changing over here? This is the particular number. This position number is the only thing it's keep on changing. So if you wish to access 10 different elements, we can't write 10 different printf statement, right? So it's better to go for looping. That's the reason we use the loop to iterate the functions. So for instance, let's say for I equals to 0, I should always start from 0. The reason is because array index always starts from the 0. So I less than 5 and I plus plus, open it. Then I just need to say printf, and I just need to access the identifier. Then I need to supply the number of I positions. That's it. So this is the way you can iterate. So I will constantly change from 0 to 4, because 4 less than 5, that's the condition. Until that, it will constantly repeat the same action, so that this position number will constantly changing. So the loop will print the number one after another. This is how you need to iterate it, right? So think about it that you not only numbers, if you wish to keep characters, a group of characters, that's also possible. So let's say char, I'm just going to say greetings, an empty array. Then I'm going to supply a string over here, hello world, something like this, right? This is also possible to keep it inside in your inside the array. All right, so now let's write a simple program like how to use the array and how to pass the arrays as a parameter inside the function. And yeah, that's what basically we are trying to do. We are going to pass the array as a function. When you are passing an array as a function, we should be very careful. We need to be very careful when you're working with array and you're trying to pass it to an array function, right? So the array can be effectively passed to a function and by a reference, right? So let's see how to do that. So here, what I'm going to do is I'm gonna hash include. So hash include stdio.h, and I'm going to create a function void print. I'm just going to print an array, and I'm going to take an array over here, array as a reference. Then I'm going to take the size of that array dynamically, because we are not supposed to fix the size like 5, 6, 7. We need to figure it out. When you're trying to print an array, sometimes it might be 5, 10. It depends on the size of the size of an array. It depends always based on the user necessity, right? So for int I equals to 0, I less than size, so loop should repeat until the reaching its size. So I plus plus, open it, and here all I'm going to do printf percentage d comma array of I, arr of I, semicolon. Right? This is what that function will do. Now let's start the int main function, open it. Here let's fix the numbers, like int num equals to 1 comma 2 comma 3 comma 4 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9, something like this. These are the numbers that we're trying to print. These are the arrays that we're trying to. So now I need to figure it out the size dynamically, right? So that's the reason I'm just going to say int size equals to, I'm going to use the size of method. First I need to find out the overall occupied size of the entire array. Then I need to divide it with the same size of the single element inside the array. Okay, so this is how you can find the size of an array. So basically this function will help, this logic will help you to figure it out. This line, the int size equal to size of numbers divided by size of numbers of 0, which basically calculates the number of elements in the array numbers, right? So let me break down this expression. So first over here, the size of this particular one. So this gives the total size in bytes, which is occupied by the array numbers, or occupied by the entire array numbers, right? And the second thing, the size of number of 0. So this gives the size in bytes of a single element inside the array. So what is the size of a single element inside the array? So this entire line, size of number slash size of number of 0, this calculates the total number of elements in the array by dividing the total size of the array by the size of a single element, right? This is what happens. The result is then assigned to the variable to this particular size. So this is what this single line expression is doing, right? Then now what I need to do, all I have to do is to printf, call that send that array numbers, then what is the size, send the size which we calculated, semicolon. Then at last return, save the changes. Now let's try to print it out. Okay, so we are getting an error. What is that? Subscribed values in either an array or not pointer. Oh, my bad. I forgot to fix this as an array. Yep, that's the reason. Save this and run it. And now, okay, so we are getting something over there which is not expected. Less than size and I plus plus, and printf, we are passing that number and we are passing that size. Let's try to let's print this printf. Let's print the size, whether it is calculating the size perfectly or not. We are getting the size as 9. Okay, but what is that symbol? I'm not sure of. It's an integer. We are getting the number only. Perfect, that's fine. Let's int array, int size, and in the loop we made it everything perfectly fine, size and I plus plus, and printf, let's printing the value and we give an empty space to understand it much better. So then we are using the same array and we are passing that index number from 0 to whatever the size it is, right? So oh my bad, I haven't even passed this to that function. number comma size. That's the mistake. I'm so sorry about it. All right, so this is okay. What's the, I figured out what's the mistake is. So not printer, because we are not returning anything. You need to directly call that function. Yes, that's the mistake I made. I'm sorry about it. Save it, and here we go. And we are getting the size as 9, and we are getting the value as being printed because I printed the value over here. Let me comment it and let me rerun it. Here we go. Look at that. See, we are getting the array values, whatever the size it is, we are getting that array value. See, if you are like, this is the best practice to figure it out, the size, right? Dividing the total size of the that entire array, and finding the size of the single element inside that array and dividing it. That's the best practice to find out the size. Okay, so yeah, this is how you need to use the one-dimensional array. All right, so what's next? All right then, so here now we are going to learn one of the most commonly used and the efficient sorting algorithm in the arrays using C. It's the quick sort algorithm. It's the quick sort algorithm. Quick sort. Quick sort algorithm, right? So let's write a program, and we are going to write it in a more efficient and in a more optimistic way to create that quick sort algorithm. You can find out what is the quick sort algorithm, and you can find lots and lots of program, and I'm going to show you the most advanced and the efficient way to write that program, right? So basically, let's understand the quick sort algorithm first. So here we need to understand that, for instance, let's say 10, 25 and 30 and 16 or something. So what I need to do is I need to compare this 10 with 25, 30 and 60. So if you wish to arrange it, so I need to figure it out. If the 10 is less than 25, so I need to swap the position. So the biggest number will comes first, right? So do the same thing for 25, 30 and 16. So this will swap constantly and it will produce the new array. Then take the next index, do the same. Then take the next index and repeat the same stuff. This is what's happening over here. All right, so what we're going to do is I'm going to keep this function. So I'm going to keep this function to print. So what we have to do is we are getting the array and we are getting the size, and we are getting the array size and we are printing the array elements. And right after this, I'm going to say printf slash. We need a new line after that, right? So over here, and I'm going to supply some random numbers over here. So delete 45, 24, 32, 12 and 2 and 53, something a random number as you wish. Then I need to figure it out the size, so which we already calculated. So then I need to print the unsorted array. Printf slash unsorted array slash semicolon. Then we need to perform the quick sort. So here, this is the place we need to perform the quick sort. Then we need to print the sorted arrays later. So to do that, what we have to do is, so all I'm going to do is going to break it into two different actions. So what I'm going to do is I'm going to break it into two different actions. Like one is for sorting and another one is breaking into the partitions, right? So we are going to create two different methods over here, right? So the method number one, it's going to be which is the function to partition the array or quick sort. So int partition, and it's going to take the array as the parameter, array number one. That's the first parameter, then the lowest index, then the highest index. All right, and then next we are going to create a function to perform the quick sort. So this is the function to perform that quick sort. So int sorry, this is not going to return anything. So void quick sort, open it, and it's going to take the array as the first index, then lowermost index and highmost index. So what I need to do is, so if over here, I'm going to check the condition. If the low is less than high, then I need to bring it, I need to swap both part, right? So we need to bring the biggest first and then move the smallest next, right? So if that condition is true, I need to find the partition index. First, I need to break it into half and I need to find that partition index. So we are going to find the partition index. So int partition index like pi is equals to, we are going to send it to this function partition, this function which we created. To the partition function, we are going to send that array and we are going to send that low most index and we are sending that higher most index as well. So this function will breaks it and it will returns that partition index written over here. So now we are going to recursively sort those two different halves. So this is the place where we are going to recursively sort the two halves, right? So first half, so quick sort, open it. I'm going to send the array and I'm going to send the lowermost value as default. Then I'm going to send the partition index -1 as a high value. Then I'm going to send the second half, just sending the complete array. Then I'm going to send the partition +1 and the higher most value, right? So this is how you need to call recursively. You need to send the first half and you need to send the second half like this way. Okay, so now the most important thing will carries out in the partition over here. Okay, so now over here int pivot. All right, so we are going to take the highermost value separately, highermost value high, because we need to compare it, right? So that's the reason we are taking the highermost. Then int I equals to low value -1. Okay, that's what. So now I'm going to use this inside int j equals to, basically we can't declare it dynamically. So what we have to do is we have to declare it over here in j. So j is going to be lowermost value, then j less than higher index, then j plus plus. It should start from the lower index and it should go until the highermost index. So if the array of j, is lesser than or equals to the highermost value, the value which we selected over here, if it lesser than or equals to the highermost value, then what we have to do, we have to swap it. So we have to swap the ARI, the array index of I, and the array index of j. We need to swap both of them, right? So to do that, I need a temporary variable. So that's the reason I'm just going to keep the temp over here. So here temp equals to array of I, then array of I equals to array of j, then array of j equals to array of I. Sorry, we do already have that value in the temp, so we need to replace it with the temp. So this is how you need to swap the value. This is how we are swapping the values inside, right? So we are getting the j value and we are sending the j value as low. Then we are trying to figure it out the highermost value. Then we are comparing it. If the j value is less than or equals to the highermost index value, then we are swapping it. So next we need to do the swapping part of array I plus 1 and the array high level of pivot, right? So over here, so what we are trying to do is we are trying to swap array of I plus 1 and array of high, which is basically our pivot value, which we already fetched, right? So the second half, this is the swapping of the first half, and now we need to move on to the second half. So again, I'm going to use the same temp value. Temp is equals to array of I plus 1. Then I'm going to say array of I plus 1 it's going to be array of j, then array of j, it's going to be the temp, right? So this is going to do the second half, and at last I'm going to say return the I plus 1. Then only this will keep on do the same stuff. This is, you don't have to worry about, but this is the second half, right? So we need to worry about that particular part. Okay, so let's make sure quickly whether we made everything perfectly, we written everything perfectly or not. So in this, we created the pivot variable and we are storing the higher most value in that. Then I need to take the low minus 1 as the I value, right? Then I'm gonna define two different values, j and temp. Then inside the for loop, I'm assigning the j index as the lowermost index. Then for the j, I'm comparing it with the higher most index. Then we are using j plus plus, not h plus plus, j plus plus. If the array of j is less than the higher most value, then what I need to do, the most important thing, I need to increment it. If I are not making the increment, then it will run into a problem. So we forget to add that increment part. Then we need to start swapping the value. So we are storing the array of I index in the temp, and we are replacing the array of I with array of j, and we are replacing the array of j with the temp value. So we are swapping it. Now we need to worry about the second part, which means the array of I plus 1, the next index. So that's the part we are doing it outside the loop, right? You need to do it outside the, if this particular if condition and this outside the looping condition. Make sure that you are outside the loop. Okay, so do the same thing. Temp equal to array of I plus 1. Then array of I plus 1 is equals to array of high, because we don't have the j, because we are outside the loop, right? So we forgot to do that because I forgot that I am outside the loop, so it should be high. Then array of high equals to temp. This is how we need to replace it. Then we need to return the I plus 1 index. Okay, so this is the thing. All right, so let's save these changes and let's check it out. So the semicolon is missing, save it, rerun it. And here also the semicolon is missing, so please make sure that you add the semicolon at every single line. Okay, array spelling wrong, save it, semicolon. Okay, so the unsorted array, which is what, 45, 24, 32 to 153, that's the exact same thing. Now let's go ahead and print the sorted array, because we haven't even performed. So far there is no logical mistakes or anything syntactical mistakes. So let's try to figure it out, is there any logical mistake? So quick sort of array, which is going to be your number. We are sending that number, and we are sending the lowermost index as 0, and we are sending the highermost index as a size minus 1. That's the highermost index. Like if we are having the 10 elements, so the highermost index is going to be 10 minus 1, which is 9. That's what we are doing over here. Semicolon, and we are trying to print the array with the number of size. Okay, and let's print this statement as sorted array, right? This is the sorted array. Save the changes. Let's check it out. Okay, size spelling wrong, my bad. Again, what's an issue? Print array. Yep, semicolon. Come on. Here we go. Look at that. See, it's sorted it completely and it's totally fine, right? If you simply change this action, that will look at that. All you have to do is to check the lower index and the higher index, so that will completely change it. If you keep it higher, so it will start from the highermost index. If you keep it lower, then it will start from the descending order, something like that. Cool, right? So this is the best practice to understand the arrays in the different ways, and this is the best practice to use the arrays, and so that you can avoid rewriting the same kind of this line, the same line here and there again and again and again, right? This is the best and efficient way for the quick sort, right? I hope you enjoyed this session. So on the next session, we are going to discuss about the multi-dimensional array. All right.